Oil analysis is a critical part of preventative maintenance in refrigeration compressors, particularly in industrial and commercial systems where equipment uptime and reliability are essential. The primary purpose of oil analysis is to monitor the condition of the lubricant and detect early signs of wear, contamination, or chemical degradation that could compromise compressor performance or lead to unexpected failure. Since the compressor is the heart of any refrigeration system, maintaining the quality of its lubricating oil is key to ensuring efficient operation and long-term asset protection. During operation, the lubricating oil not only reduces friction and heat between moving parts, but it also assists with sealing, cooling, and carrying away contaminants. Over time, however, oil can degrade due to thermal stress, refrigerant dilution, or contamination from water, acids, or metal particles. These changes may not be visibly obvious, which is why routine laboratory analysis is used to evaluate the oil's physical and chemical properties. Parameters such as viscosity, total acid number or TAN, moisture content, refrigerant concentration, and metal content help maintenance teams determine whether the oil is still fit for service or if corrective actions are needed. There are several critical warning signs that oil analysis can reveal, prompting the need for oil replacement. A significant change in viscosity, either too low due to refrigerant dilution or too high due to oxidation, can impair the oil's ability to lubricate moving components effectively. A high total acid number indicates that the oil is breaking down chemically, often due to oxidation or moisture contamination, which can lead to corrosion of internal parts. The presence of moisture in the oil reduces the oil's film strength and can form harmful acids. Another red flag is the detection of metal wear particles such as iron, aluminum, copper, or tin, which may point to mechanical wear in bearings, rotors, or valve plates. Darkened oil, a burnt odor, or visible sludge formation are also signs of thermal breakdown and contamination.